Hello and welcome everybody to another tutorial. In this tutorial we'll talk about tearing up vellum cloth and reveal the service beneath it, and it will be with a custom attribute that is be dynamically animated and will not just only bump at the beginning of the animation but through the time. So as you can see here, running the frame, then suddenly it will pop from back to the front. Another simple example, this flag will start to tear slowly, and we will go through this file first so we can take the principle and apply it to the car, so we'll make it more clear and more understandable. Okay. Also, you are very much welcome to support me on my Patreon page, where you will find all of the scene files included that you can download and play with and update. Each tutorial I'll put the scene file there, so I appreciate your support and your continuous encouragement and feedback. I'm also available on Gumroad. Also, you can see most of the file scene also included here, so feel free to browse through the files, and thank you for your support again. On my YouTube channel also, you are welcome to join the membership, where you will see exclusive tutorial, so see you also there. And now let's start and go and talk about the scene file. So this is the first scene file, so let's go to the first frame. At the top, the object level, we have a couple of cameras and environment light, and this is where the setup. So at the beginning, let me remove this one and go to the first node, which is simply a grid. Let me remove this one and make the lighting easier, and the background make it dark. So this is the grid. We applied a remesh, so we don't have straight lines. So when we do the edge fracture, we will have a jagged edge. So this is the edge fracture node. Here I added 200 pieces and I activate the primitive piece. So let's view it. So as you can see, each color will represent one piece. So the fracture will happen in between the pieces, which will give you a very nice look for cloth tearing. I added assembly in case we need it, but I didn't use, because I have a couple of vellum objects, so it's always better to have a group for each object. So this one I call it flag, and it's running on the primitive. Next, we have the vellum cloth now. The first one is a cloth. Let me expand this one a little. So it's a cloth type, and the calculated mass density is very low. I keep the thickness as is. The stretch, I keep it at 100,000, so it can be stretched with enough force. And the bend, I kept it very low here. And this is the group: flag bend and flag stretch. So for the stretch, we have this group, the stretch constraint, we have this group. Like if I add it here, a null, and view it. So these are the constraints. Let's add a blast now. And here we should have two group: flag bend and flag stretch. So delete non-selected. So this is the constraint for the stretch, and this is the more complicated constraint for the bending. Okay. Next, we added a vellum welt And the idea with the weld, it will create a weld attribute plus bending, if I rotate, bending constraint between each pieces. Okay, so they will look like they were sewed together. So this one called weld, and it's very low in stiffness. Now one thing, so the attribute also is called weld. The geometry spreadsheet, let's hide everything and view weld. So if you can notice, I am not in the constraint, I am in the Vellum. Here we were in constraint. Okay, in constraint all attributes are located at the primitive level. So notice this one. Okay, pay attention for it. So Vellum weld, it will live on the points of the geometry, not the constraint. So when I view the constraint, nothing. These are from the previous constraint. Okay, so all manipulation will be done for the weld, as you can see here, on the point level. The equivalent node for the weld, if you want to manipulate on constraint, is to have it stitch point. So with the stitch on the geometry, you will not have the weld, but here let me give it a name. Let's see how it looks. So these are the constraints. Just remove these in a way. So the idea on the geometry, you will not have the weld, but you have the constraint here, and let's say its name is stretch. So in the geometry, in the Vellum, you don't see anything related to the constraint, but if you go to the constraint on the primitive, you will see the constraint parameter. Okay, so pay attention for this one. This is weld, live on geometry. This is stitch, live on the constraint, back. So we have our sewing or welding. We added the Vellum back. That will compress all of the geometry constraint, and if we have collision, into one node, which is easy and more organized if we have multiple objects. On the other side, we have a grid that I scatter some sphere on it, some mountain, scattering total of 10 points. We randomize the B scale and we copy the points. That will represent the balloon, and we give them a group called balloon, and same thing, a cloth with simple parameter, straightforward, not very stiff, and we have a pressure that's up to 2 with a stretch of 60, and we back. Now we merge both of them. The one thing remaining is in the flag, in the Vellum cloth, I pinpoint the edge. I go here, this edge, so they don't move. Okay. After we merge, we add the Vellum and back, and we have a tube that will represent the pole. And now in Vellum solver, I'm solving on 2 steps. I have velocity damping activated at 0.02, and that's it at the top. Inside we have a subsolver and geometry wrangles. Why we have these? I will show you. Because I want the weld to start to disappear according to the timeline here. So not on the first frame, because you can go here in the weld and activate breaking threshold. So when this threshold is met, it will start to break, and sometimes it will break all of it together. So I wanted to create some attribute that is spreading across the flag and activating as necessarily when a criteria is met to delete or disable the welding. So here, when I was on the edge fracture, I added mob spread fall off. Let me activate it. And here in the start point, I choose a random point somewhere at the edge, say here, and I animated it, and the spread is being animated also, so it will start gradual, then stop, then again start spreading with some noise and remapping. I didn't add the remap, so let's view it. See, stopped and start again. So it's not spreading to the whole area. I don't want the whole flag to be lost. Maybe we can add another point. So we'll add one point here with pressing shift. Add another point here. Enter. So let's see now. See, at the end it becomes very strong. So we have this attribute, and it's called mobs fall off on the point attribute. Okay, remember it. So see, I'm connecting it somehow, referencing it back to the Vellum solver. What I want to copy the fall off from that node to the flag points. So I'm using subsolver and I'm running it on the geometry. Here I'm referencing two things. I'll come back to this one, but here I'm referencing the shape that we talked about, this one, and I have here the dop geometry, the flag, and I'm transferring the mob fall off, and I'm out. Stress, I'll come back to it. So I have the fall off. Where is it? Somewhere here. Let's go here. Fall off, fall off, fall off. Maybe I need to run one frame at least. Because I don't have the value yet, still it's not running, because we will run it. No, here it is. I see it. Yeah, because the value will be 0. So here, because I'm running on points, I don't use the Vellum constraint property. This is for property of the constraint that we need to modify with Vex, for instance. But for points, geometry, I can use geometry wrangle, and I'm running on myself because already I copied the data to the flag. And here the code is straightforward. I created a float called A. Let's view it. Hide all, give me A, give me fall off, and the stress for later use. So I have A being copied, 0, and start to increase. too slow. Okay. And I view it. We'll see. Here we cannot view it. Anyway, if I go here upstairs to the Vellum solver visualization, the stretch, and also I want to bypass the merge and connect these directly. It will run faster. Here I'll just make it one sub-step for a quick access. So this is the stress. Good. So I'm taking that, no, this one for the next. We'll talk about this one. I'll come back for it, okay? But here, if mob fall off that we copied is more than the stress, I'll come back to it, multiplied by 50, then how I reset or default the weld, I make it -1. So when it's -1, it is infinite, so the solver will treat it as broken, for instance, or deleted. And I'm putting it all in group called fall. So what's the stress story? As you can see here, this is where the stress is spreading. So I want to compare against this stress, but the stress is living on the constraint. So I want to take it from the constraint and put it or copy it or transfer it to the point, the geometry. So that's why here I object merge the constraints, double import the constraints. These, the bend and the flag stretch, these two constraints that we visualized previously, if you remember the shape. And as you can see here, they have the stiffness and they have the stress. This is what we want to copy. So I'm copying it as a primitive and exactly on the flag, because I don't want to copy it to the balloons. And attribute promoting from primitive to point, because I'm dealing with points when I work with geometry. So that make our code complete now. So I'm fitting, because if you look at the stress, its value will be very high. So I'm fitting it, as you can see. Later on it will go even higher, between 0 and 1, and this is where I do the multiplication, and I get my weld when it to become -1. So let's view the weld here. As you can see, each point with its corresponding point, and the one that is not being weld will be -1. So let's have a look. Let me run it for a while and share the result. So this is the preview. As you can see, according to the stress, the weld will be -1 and it will fall down. See the blue color. Interesting. Now the other thing, if you can notice, the wind is going this way, but when they fall down, immediately they go sort of to the ground. And the way we did this one is here. We have any points that meet the condition will be added to the group called fall. So integer at group underscore, and we call the group name whatever we want, equal 1. So here in the bob wind, it's affecting everything except the fall group, so not fall. So this is how they move. Then there is a bob force only affecting the fall and also the balloon, that make them go down also. Not go down only, but to this side also, a little bit slower than the previous one. So after that, we added a Vellum poster process, with spatial blur of 1 and looping of 2 with detangle. And here I'm splitting to add the UV for the flag, time shift, UV texture, and I'm transferring the UV between the flag to the flag. On the other side I have the non-flag connectivity. Because I remove it from here, let me return it. And this one here. So we have the balls with connectivity. I'm running on each balloon, adding quick UV shade on the Z and rotating it a little bit, and taking the output. So this is the logo of my channel. Then it's a matter of applying material with lighting and exporting. And this is the result for this part. Okay, now for the car, I will go quickly and talk about it. You will find the scene file in my Patreon. So we did the same maneuver, same thing. The only extra add-on is I'm defining only the body of the car. So I'm splitting only the body, adding delete group. This group is according to the normal -1, so I'm deleting all the bars looking down, blasting this group, then I'm baking it a little bit so I have the cloth group, delete, remove any group, and according to the connectivity class, see this is the connectivity, I'm fusing it again to make sure I don't have separated points. Then I'm doing Boolean, so it will be one piece, and running for each. For the part like this part, I'm subdividing it, then remeshing and adding poly reduce, so I have this jagged shape or lines, so I can add my edge fracture, because without this one, if I leave it as is, see it's very straight. So this one I have it looking more natural. This is the output. As you can see, a lot of patches. I'm adding facet to remove any degenerated points. See, like these points in white being removed. Poly reduce it more, and running through the same setup as before, and this is the outcome. So hopefully you enjoyed this tutorial and you get the idea between being weld on bond geometry against being stitched on the constrained geometry. Thank you very much, and wish you to see in the comments down below, because there is a lot of method to do the same principle, so you can share your idea so I can learn from it. And don't forget to like, subscribe and share and leave a comment, and support me on my Patreon and Gumroad. Have a nice day and thank you very much.